Hey, welcome back for another video on malware development. In this video, we're going to cover payload staging, specifically web-based payload staging. If you're tired of your payloads getting picked up by antivirus, then web-based payload staging may be the solution for you. Web-based payload staging gives you the ability to offload the important components of your payload or your malware. That way, when signature scanning or AV scanning in general is running, the core components of your payload aren't there to be detected or signatured. There are three major components that we're going to look at today, and those are the file itself that we're staging, our actual payload. In our case, it's going to be shellcode. We're going to use the MSF Venom calc shellcode that we've used in previous videos. We're going to look at how to host this payload. We're just going to use a simple Python server to host it. And then we will look at how we can download and inject that shellcode. So let's go ahead and get started. We're going to start off by opening up HXD hex editor, and I already have my shellcode created, so I'm just going to paste that shellcode in here. And you can see here, this is your familiar hex values, FC4883, and down here your calc.exe. So this is the standard calc shellcode that I use for every video, and I'm just going to name this data.bin, and that is on my desktop. I'll close that. So we've already done this first section. We can go ahead and knock that out, and then we'll look at how we can host this shellcode. But before that, I do want to hit on the disclaimer real quick. The content in this video is for educational purposes only. It's not intended to encourage or support any illegal activities. Don't do anything stupid with this data or this information that you learn in the video. And now back to your regularly scheduled content. Okay, let's go ahead and get started. Back to hosting the shellcode. So I have a PowerShell window here, and I have Python installed. I have my path variable set up and everything. So all I really need to do is just run python-m http.server, and I'm going to bind it -b to bind to my local host, and that should open up port 8000, and it's just a simple web server that's essentially hosting the files on my desktop. So I will drag this off screen, and we have done the second component. Pretty simple so far. The third step is to download and inject the shellcode. So to do that, what we're going to do is we are going to make a web request to our locally hosted HTTP server. You can imagine this being like Google Drive though, or GitHub or something like that, somewhere else where you're hosting your payload. And we'll download the shellcode, and then we'll inject it like we always do. So I am going to go ahead and get started coding. Here we go. So first thing we want to do is include our headers. We'll start off with the Windows header, and then we're going to use WinHTTP a lot, so we'll include WinHTTP and IOStream, and then vector will hold our buffer data. So we want to link against the WinHTTP lib so that we can use that header file, and we'll create our main function. First, what we want to do is we want to use WinHTTP open to initialize the WinHTTP functions. This returns a WinHTTP session. Our first parameter is the user agent, and the rest is setting up permissions and proxy. Next, we have WinHTTP connect. This will take our HTTP handle, and this initializes the target server for our HTTP request. Following that, we have WinHTTP open request, which takes the HTTP session handle, and this is what actually takes our parameters for our GET request to data.bin. And then we'll use when HTTP send request to send that request. This returns a boolean. And we'll pass it our handle to request from when HTTP open request. So following that, if the boolean is true, if we do have results, then we'll set results to when HTTP receive response. This function waits to receive a response from the HTTP request. Then we're going to initialize our dword size, the dword downloaded, and the vector char. But you can see here I typed remove const by accident instead for our buffer, and then the bool done. So if we do have results, then we want to set dword size to 0, and then we'll use when HTTP query data available, and that will return this will return the amount of data in bytes that is available to read. If there is no data or it returns 0, then we'll just end there. Otherwise, we're going to resize our buffer to the dword size, which is what was returned by the when HTTP query data, and then we're going to zero out that section of memory. And then after that, we want to read the data. So we'll use when HTTP read data with the handle hRequest, and we'll pass that data to our buffer. Real quick, I also want to mention that all this code is available down in the link below in my GitHub repository. If you like this content, please make sure you like, comment, and subscribe. It will really help out the channel. Now that we've read the data, we can fix our vector char buffer. Okay, so now that we have this set up, that we're retrieving our data, now we want to use, so now we have shellcode in our buffer. Now we just want to use virtual alloc like we normally would to allocate a section of memory. We'll do that using the size of the buffer, and we'll use memcommit and memreserve, and we will set our permissions to page execute read write. And then following that, we want to copy our memory or copy our buffer data into our pointer address. So we'll pass buffer data and buffer size, and we'll move that into our exec pointer, and then we'll execute. You need to cast exec as a function and execute it. And then finally, we just want to clean up any handles that we have open. So we'll check if we have handles available. If we do, we'll use when HTTP close handle to close the handle. And we'll do that 3 times, once for hRequest, once for our connect handle, and once for our session handle. And then finally, we'll just return 0. Okay, so now if everything went well and looks good, we should be able to run this, and it will download our shellcode and execute it. Let's save this, and I will press the play button. Let's see what happens. There we go, we got our calc. And if I bring this window back over, you can see here a get request to data.bin with a 200 OK. So this is where we made our HTTP request to download the payload. So awesome, there we go. And if we go check virus and threat protection, we can see that real-time protection is turned on, and we did not get any any alerts or blocks. So that's what we want to see. And like I said before, if you do like this content, please make sure you like, comment, and subscribe. It helps motivate me. It'll help the algorithm and all the things. So if you have any content that you'd like to see in the future, just comment it in the Discord or down below, and I'd be happy to make it for you.